At A Cloud Guru, we seamlessly integrate hands-on learning every step of the way. We call it Learn by Doing. Why does that matter? Because just watching a thing won't make you a pro at that thing. Watching can lead to knowing.
And knowing is half the battle!
But the other half? That's doing.
Oh, God, this guy is hilarious.
This is Lars.
Who said that?
He's part of our crack team of engaging tech wizards who weave together courses, labs, and sandbox environments into one buttery smooth interactive learning journey. Other platforms give you a fragmented experience. Watch a boring lecture, then figure it out on your own.
Do what?
Good question. With A Cloud Guru, learners code along with instruction, learn faster, and retain more. 85% of people say they retain more by getting hands-on with A Cloud Guru. How's it work?
No idea.
With hands-on labs and Cloud Playground. Hands-on labs are guided exercises that put skills into play around practical scenarios. We offer more than 1,400 labs, including meaty deep dives and snack-sized how-tos, ideal for picking up new concepts in as little as 15 minutes. Then there's Cloud Playground. It lets learners practice in real and safe AWS, GCP, and Azure environments. Get unlimited access to almost any service at zero extra cost. Take real servers for a virtual spin. With no surprise bills.
What have I done?
And no fear of breaking anything. And no downloads or open insecure ports on the corporate network required. With A Cloud Guru, you can put these on this, so you can get these. Learn faster, retain more with A Cloud Guru, the leader in cloud learning.
Hello?
Hello, everyone. Welcome. I'm Nancy, and welcome to the OWASP DevSlop Game Day Recap and Solution. So you may know, a few days ago on Sunday, we held our first ever DevOps Capture the Flag competition, where participants were able to use Docker to containerize an existing 3-tier application, front-end, back-end, and database, and deploy it to a Docker host running on AWS. So there were more than 200 registered participants, but we ended up with about 190 around 48 teams across 48 teams. From all around the world, at least 14 countries: the US, Ireland, Iran, UK, Brazil, Sweden, Switzerland. I won't name them all, but you were from everywhere. So we were quite impressed and amused by that. The winners, we had 3 teams that came up on top. First, emergency meeting. Not sure if the whole team was from Canada, but at least one player was from Canada. And then Midnight from Sri Lanka and Gambiara from Brazil. So for today, the plan is to let Renan go over everything, go over what the challenge was and the solution. And we have also some question for you. And at the end of that, the winner will come out with a prize. So here we go. Hi, Renan.
Hey, Nancy, how's it going?
How about yourself?
Very good. Very excited about this.
So what's your plan for today? I know I mentioned a few things. How are you going to, what's the agenda?
Yeah, so I'm just gonna basically go over all of the tasks because I know, some people weren't able to participate and others weren't able to finish. So we're just gonna go, go through all the tasks together. For those who participated of the event, the infrastructure is up and running. So if you want to follow along with us here, feel free to do that as well. But yeah, so I'm just gonna, show CTF. We're gonna go task by task.
Awesome. So I'll let you go first.
All right.
Go ahead.
Okay, perfect. Okay, so this is CTFD. So that's the platform that we used for the event. And so the warm-up, I'm not going to go too deep into the warm-up because I went through, during the event. But just for those who are not there, I'm just going to quickly explain what's the solution that we're going to be building today. So this is an architecture diagram of the solution. And basically, we're going to be deploying a 3-tier application to a Docker host, meaning an EC2 instance on AWS. There are going to be 3 containers: front end, back end, and database. Each one of these containers, they're going to run on their own Docker network. And we're just, at the end of this, all of this task, we should be able to access the front end and be able to log into it and see a bunch of tasks, since this is a to-do application. And then for each one of those tasks, we're going to have to capture the flag. That's why the event is called CTF. And so this is the format of the flag. So it's DevSlop, CTF, and then within the curly brackets, this is the flag that we're going to obtain. So if you're in the event and you're wondering what are these flags, so this is basically what they are. So every time we submit a flag, I gain points. And that's how we had the winner. So whoever got points faster. Right. Okay. So I'll submit this one. Yep. So it's already solved. And same thing with the getting started. Getting started was just to give everyone access to AWS. I was just explaining how to get access to Cloud9. And I've already got my account here. So this is the same interface that everyone had during the event. And okay, so let's just go through it now. The first thing we need to do is to clone the to-do application, which is on GitHub. So this is the link. So let me just copy this, and we could do a simple git clone, but I've already got everything because I've already cloned before, but we just need to do a git clone. And then if you do ls, we're gonna have a folder called docker-ctf. I'm just going to go into that. And you see that everything that is inside the folder environment, it's going to show up on the left here, right? So if I open this, we have the backend, the database, and the front end. And then at the end, this is pretty much just it. We're just, going to clone the repo and submit another flag to get 5 more points. I've already done that. So let's go to task number 1. Okay, so task number 1 is to basically build the client application, the front end. So in our repo, there is a folder called front end, and there's a file called Dockerfile. So whenever you want to build a Docker image, so this is usually what we use. So this is a Dockerfile which contains instructions to tell Docker how to build this image, right? And then here on the bottom, we have a few requirements. So first is there is an instruction called from, which means that what's going to be your base image, right? Because whenever you build an image, you need to start from somewhere. So here we have node carbon, And the reason why I'm using Node Carbon is because this image already contains Node.js for me, so I don't have to worry about installing it. I could use, an Alpine or something like that and install Node myself, but because this one is already done, I'm just gonna leverage it. And then we have the instruction run, which we can run commands, right? But before we get to that, we need to, let's just read this just so it's just so it's clear what we need to do. So we need to start the image from Node Carbon. We need to copy everything that is in the repo that we cloned into that image. Then we're gonna make sure that we start working from the folder called /code. So that's gonna be the working directory. Then we need to run npm install to make sure that all the dependencies are there. And then finally, the CMD is to actually run the application when we run the container. So first thing I'm going to do is to copy everything. I'm going to copy from dot to /code. And here note that, /code in theory doesn't exist, but once we build this image, it's going to be created for us by the copy instruction. So I'm going to copy everything that is, in this local directory inside /code. And then every time I run the container, I want the starting point to be /code. So that's why we have something which is called work directory. So work there. That's going to be /code. And then after I set up everything, so I've got the code there, I need to run npm install. So I'm just going to do run npm install to install all the dependencies. And one thing to note is that I remember someone was putting npm install before everything here, and that's not going to work because unless you have the code inside the image first, that's when you can install it, right? So you cannot install before you copy the code. So that's why npm install needs to come after the copy command. And then finally, we have our executable. So our executable is going to be npm run dev. And note that I cannot do everything in a double quote, so npm run dev, because this is translated into a single command, right? So then the system's going to think that there is a command called npm space run space dev, which is not true. So the command is npm. So we finished there the quote. Then we put a comma around run. So that's the first argument. And then the second argument is dev. So you first have the command, and then for each one of the arguments, you just separate them in quotas, so in quotes and commas. All right, so this is Dockerfile for the front end. I believe I didn't miss anything. Just gonna go back here to double check. And I think we have everything. Okay, so now it's time to build the container. So make sure this is saved. So if I do ls and let me go to front end first. Cat Dockerfile. So you can see that everything is there. It's already saved, which is good. And so for us to build a Docker image, there is a command called Docker Build. And we need to specify an option called -t, which is for the tag, and this is basically the name of the image. So based on here, it should be ddfe. So let's call it that. And then at the end, I need to specify dot, because I need to tell Docker where to find my Docker file. If your Docker file is somewhere else, you could have an option to specify the path to this Docker file, but because it's in the same directory, I'm just going to specify dot. All right, so I'm just going to wait for this to build. And as I go through this, if you have any questions around anything, just send here on the chat on YouTube or Twitch, and we'll answer it. Especially when we build and push images, we're all gonna have some time to chat. That's not instantly. Okay, now it's npm install. And I think I'm going to mention another thing as well that I remember that happened during the event. So I remember a case where a team, so they ran npm install, in Cloud9, and then they copy all of the code to the container. So one thing to note when you're doing that, especially if you're working on different platforms, like if you're building things on Windows and you're running containers, which is Linux, whenever you install things, let's say on Windows, and you copy to a container which is going to run Linux, it's not going to work, right? Because the architecture is it's different, etc. So that's what happened. So if you did an npm install in the Cloud9 environment, and then you build the image and you copy everything over the image, so that's not going to work. You're going to have some errors. So make sure that you do npm install inside the image that you're building. Okay, so let's see what's coming next. All right, so after we build, we're just gonna run the front end, and we should be able to see a message at the bottom. Okay, so it's done. So I can do docker run rm. This rm just remove the container once everything's done. Once the container is killed, just removes it. Dash or dd-fe. See what happens. All right. Okay. So this is the message that we got here at the bottom. Compiled successfully. Going back to the challenge, we have this redacted, and this is basically the message that we're looking for. Now, what we need to do to capture the flag is to grab that message without the period at the end, and generate a SHA-256 hash of that message. And then the first 6 characters, that's going to be our flag. Right, so basically I'm just going to copy everything here. And you have a couple of options. You can either use a command on here on the terminal, or you could use a hash calculator website like this. So if you just paste everything, this is the resulting hash. And then the first 6 characters, which are these ones until ff, this is going to be the flag. So what we can do is come back here and then do DevSlop ctf curly brackets and then submit. And there you go. So that's the flag for task number 1. Now let me close this, open task number 2, and here I can stop. So task number 2 is going to be to push the image that we just built to DockerHub, right? So we're gonna be running our containers in a separate machine. It's not going to be on Cloud9. That's why I'm going to first push to DockerHub, and then I'm going to go to that machine and pull the image there. Now, for us to push the image to DockerHub, there's something we need to bear in mind. So if I do Docker images, the name of my image is dd-fe, yeah? But for me to push to DockerHub, I need to include my username and the image name, yeah? So my username is the Dojo series. So then this means that the image name should be the Dojo series /dd-fe, right? Otherwise, if I try to push this, so if I do docker push efe, let's say denied, because if you don't specify a username, that's basically like the main, how can I call that? We call the index, right? So that's the official repos, So for us, we all have usernames, but if you don't specify anything, that's the official ones, right? So that's why you're not going to be able to push unless you specify your username. Now, there are 2 main ways we can do this. We can either build the image again and use a different name, or we can just retag the image. So let's just learn how we can retag an image. We're going to do docker tag, specify the current name, which is dd-fe, and then we specify the username, which is, in my case, is the Dojo series /dd-fe. And then if I do a docker images, we can see that there is a new tag, Dojo series dd-fe, and so this is the one that we need to push to DockerHub, right? Now, if I do docker push, and then actually let me just bring it up and do a docker push here. what's going to happen. So it still says denied. And the reason why it's denied is because I first need to log into my account, right? Because otherwise everyone will be able to push to everyone's account. So if you want to log in, and I'm not saying to log in, in the browser, you need to log in via the Docker CLI. And so if I do Docker login, username. Give me 1 second. I'm just going to grab my password. Okay, so it says login succeeded. Now I can try to push again. And one thing to mention here is that you notice that usually Docker images, they have tags. Yeah, so you have the image name and then a tag at the end after the colon. Here, I didn't specify anything. And if you don't specify anything, then the name of the tag is going to be latest, right? So that's the convention. It's going to be called latest. But if you want to use a different name for the image, then whenever you build, you can just specify that. It's a bit tricky to use latest because you don't really know what version is that, right? Because it only says latest, nothing else. So you don't know which version is that. So that's why I see a lot of people actually using, for example, the git commit hash, right? So whenever you commit your code, that's going to generate a hash, and then you can take part of that hash and use as the image tag. So then you know exactly which commit is inside that image. Okay, so I pushed everything now. So everything is in DockerHub. Let's go back here. Let's see. Yeah, so that was everything. And now we just need to capture the flag. All right. And one thing that I saw here, there is a comment. So for someone just beginning, we'll be able to more or less do so with our own AWS account. Yeah, so the setup here, it's very simple actually. So you only need one EC2 instance, that's it, that has Docker installed. Use the Amazon Linux AMI if you can. So that already comes with Docker, so you don't have to worry about installing Docker. And then everything that I'm doing in Cloud9, you can do locally in your machine. You're gonna push all of your work to DockerHub, and then you're just gonna SSH into the instance and continue the challenge there. So if you want to do in your own AWS account, launch an EC2 instance with Amazon Linux AMI that already has Docker, and you can just do the challenge. So the setup on AWS is very easy. Okay. Now the flag. So the flag is this is the message that we're gonna get after doing Docker push. So we need to get a few components of that message. So the first word before colon, that's latest, which is the image tag. If I chose another tag, you'd see something different here. So let's do the flag. So DevSlop CTF latest, and then colon. The second thing after that is digest. Third one is something before the hash, which is this one here, SHA-256, colon, and then the last thing is something before a size, which is exactly the word size. All right, so that, I believe that was the flag. Let me submit and make sure everything is okay. Okay, so I missed something. 1 second, let's see here. Oh, I know what it is. This is case sensitive, so it needs to be CTF all uppercase. I think that's what I missed. Yeah, all right, there it is. Okay, so that's the flag for task number 2. Now moving on to task number 3.
Renan, I didn't interrupt you the first time, but did you want to do the quiz?
Oh yes, of course. I forgot the quiz. How could I have forgotten that?
Yeah, was it
okay,
true?
let's stop everything then. Let's go back all the way to task 1.
Task 1.
Yeah.
Okay.
Yeah. So basically, yeah, what we're gonna do is like after each task, we're gonna play a little game, right? And then Nancy's gonna show you a question, and for those who answered, the majority of the questions correct at the end, we'll win a prize. Okay, so for task number 1, let's see how we can do that, Nancy.
Okay, so let me share my screen. Just a second, right here. So you should see this. So I'll share the link in the chat as well, but basically copy link here. It's basically you go to joinmyquiz.com. If you use the link, you'll be right there. Enter the code 387006. And once you're in, so people are coming in. I will warn you, because YouTube and Twitch have a streaming delay, you should look at your device because the question will come to your device first, right? If you wait until it comes to the YouTube channel, you might be late. You might have the answer correct, but you won't be fast enough. So look at your device. It will come to it first before it comes to the stream.
Yeah, and I wanted to mention that speed is everything here. So you need to answer correctly and as fast as you can.
Exactly. We'll wait because I tend to wait maybe 20 seconds until nobody else is added. We're at 14. Another 10 seconds. One more. And 9. Should we go?
Yep, let's do it.
Let's do it. Okay. The answers are coming in.
Yep. Guess we can give them about a minute. Yeah, and this is something that I actually didn't mention when I was going through this, so it might be a little bit tricky.
Four more people have to answer.
Meanwhile, so there's this question if CTF is going to be open only during the stream today.
The CTFD can be open as long as very long. It's more of the cloud environment. I guess it's the cloud environment ends around 2 or 3 p.m. But CTFD can be open for days. That's not an issue at all.
Yeah, and also the challenge is on GitHub, so it's pretty much the same thing. If you have trouble finding the challenge in CTFD, you can find on GitHub.
Okay, 2 more. I think that's been about a minute. I'll move on. Should I move on to the next one?
So let's give him 10 seconds.
Okay.
3, 2, 1. Okay, let's end.
Let's go.
All right.
Okay. Quite a few people got it. So 7 people got the answer right.
Cool.
Do you want to go over the question?
Yep, I can go ahead. So basically, whenever you run echo message and then you pipe that to that command, the problem with echo like this is that it's going to put a line break at the end, right? So if you want to remove the line break, then you need to do echo -n. So that's going to remove the line break, and that's actually going to be the SHA 256 hash of the string message. So that is the answer. I guess we can go to test number 2, right? Since I skipped that one.
Yeah, let's go.
This one should be easier to answer.
You can see it. People are.
Yeah, very quick.
Another 5 seconds.
Yep.
Oh,
One more. Come on.
let's
You can do
go. Let's go. Number 20.
it.
5. And let's go.
All right. All right.
So Image still in the lead.
Yeah.
Oh, yeah, a lot more people got this one right. 16 got it right.
Yep.
That's awesome.
Yeah. So the answer to this one is that the tag is going to be latest if you don't specify anything. So if you go to DockerHub and you go under the tab tags, you're going to see latest there if you don't specify anything.
So I'll move on to your slides.
Yep. Let's go back and do test number 3. All right, so now test number 3 is we're gonna deploy the image that we just pushed to DockerHub into our Docker host, right? And first here, I'm just showing how you can SSH into it, and this is only gonna work if you're using our environment. But if you're using your own EC2 instance, then that's gonna be a little bit different, right? So it's probably gonna be a public IP if you're working from a local machine. So just bear in mind, you just need to SSH to the instance. So let me just do that quickly. I'm actually going to open a new terminal. So I have both of them. And 2. Right. First thing is just to run, hello world. This is just to make sure everything is working. I'm not going to run it now, but then what we need to do later after that is to pull the image, right? Okay, so to pull an image from DockerHub all the way here to my instance, I do docker pull. And remember that you need to specify the DockerHub username /ddfe. And one thing to note here is that, so this repo that I have is public, right? But when I push to it, I had to authenticate. But now that I'm pulling, I don't have to. And the reason for that is that even though the repo is public, I'm the only person that has write access to my account. That's why I need to log in when I'm pushing. But for pulling, this is like a public GitHub repo, so everyone should be able to clone it, right? And that's the reason why I don't have to log in when I'm pulling. Okay, so I have everything here, so it's already downloaded. And next, we need to run that image. Notice that even though so there are two ways. If you run Docker run, so if you run Docker run and you don't have the image locally, it's gonna pull for you. So you don't necessarily need to do a Docker pull and then Docker run. You can just do Docker run directly, and if it's not there, Docker is gonna pull for you, which is nice. And all right, so now let me just do Docker run and -d. So -d is like in detached mode, which means background. So -d and then the name of the image. And you see that I don't see any output. And if I do Docker ps to list the containers running, what I can do is do Docker logs to get the logs of the container. And this is gonna retrieve the logs until then. If you want to, keep watching the logs, you can use -f. So -f it's like tailing, right? So it's gonna tail the logs. So, but here it's done, so it's compiled successfully. If I do Docker PS, it's still running. And then the next thing we need to do is to open this website to see this interface. Now, for us to open this, I need to obtain the public IP address of my instance. There are two ways you can do that very easily. So one of them is AWS has a metadata API that contains a lot of information about your instance, including the public IP. But for me, one of the easiest way is to just curl an address called efconfig, which is a Unix command .co. That's going to return the IP address of my instance. So I can copy this and see what's going to happen. So it's supposed to be on port 8080. So there is nothing running there. We cannot access the website. Now let's take a look at why. So if I do a Docker PS, we see that under ports, there is nothing here. Right? It's a little bit hard to see, but basically ports is in this part here. So there's nothing, which means that there's no port allocated for the container. So the traffic is not able to actually go in there. So what we need to do is rerun the container, exposing port 8080. So I'm basically just going to stop the container and then remove it. And let me bring up the command again. So docker run. If you want to expose the port, what you can do is -p. And then with -p, you basically have the host port and the container port. Right? So if you want the host port to be something different than the container port, you do host port, and container port. If I want them to be the same, you can do like, for example, 8080, 8080. So the traffic will come to the instance on port 8080, and then it's going to go into the container, and the container's port 8080. So let me run that. And I just want to make sure that nothing's going to break. I don't think it will, but just in case. Okay, compile successfully. Now, if I do a Docker PS, we see something a little bit different. So we see 0000, 8080, and then there is a little arrow, 8080, right? So that means the port is allocated and we're able to access the container from outside the instance. One thing I remember that happened during the event, so someone had, instead of 000, they had 127.0.0.1. And if you have 127.0.0.1, that means the container is only going to accept, or the instance is only going to accept traffic coming within the instance, right? So traffic from outside will not be able to enter the instance. That's why you need to specify, or if you don't specify anything, which was my case, it's gonna say 0000, which means every IP address. So that's why we'll be able to access it. So if I reload this, and there you go. So that's our website. Let's come back here and see if there's anything else. I don't think so. I think it was just loading the website. All right, and then for us to obtain the flag, so this is task number 3. What we need to do is we need to bring up the developer console and then go to network. So let me just reload this, and then I'm gonna click on login. And all right, so basically when we click on login, the front end is trying to talk to the back end. But if you analyze the network traffic, we see there is a post which is failing, and the address is a little bit weird, right? So you've got backend_IP 7777. So here we're supposed to have the backend IP, which we haven't worked on the backend yet, but the flag was basically to obtain the IP address, or the DNS name and the port. So the answer for this, the flag would be backend_IP : and then the port. Coming back there were 2 hints. If you needed, one of them is to how to obtain the instance public IP, and the other one is to how to make it accessible via the internet. Right, so it's DevSlop CTF. So that's the correct flag for task number 3. And I think it's quiz time before I forget.
Yes. Before we move on to the quiz, there's a question in the chat. I know you don't do pen testing, Renan, but do you have anything to tell us about securing or Docker? Please. The question is, please suggest how to implement security in Docker and pen testing of Docker. That can be a long topic, but maybe.
Yeah. Yeah. So yeah, for Docker, there are a couple of layers, right? So first is the security of the host itself, right? And there's also the security of the container. For the container, there's a bunch of things that you can you can configure in terms of the system. When you build an image, there is things like, for example, don't give root access. So what we're doing here, so let me go back to AWS quickly. You see that I'm not creating any user. I'm not setting up any permissions, which means that whenever I run the container, it's running as root, right? This is not best practice. We're just doing this because we're just learning Docker. But when it comes to security, it's very important for you to also lock down the container. So don't run as root, right? The same thing you wouldn't do in a machine. But to mention one website that I actually used to learn this thing. So there is a website called Catacota, and this might be useful for a lot of people here. So if you go to Catacota, you go to learn. There is one. So this is basically like they launch an environment for you, and you can go through. It's very similar to what we're doing here. There are like a bunch of tasks. You can go over the tasks and learn a lot of things. There is a Docker one for security, which is going to show you how you can secure a container. I think it's this one. So if you go to Docker, container registry, this one, Docker security, right? So there is this course on Docker security, and there are 10 scenarios, which means like 10 tasks. And this is going to go a little bit deeper into like a lot of the parameters that you can use to secure Docker containers and also the options. So yeah, so I would highly recommend that you can, just take a look at this course.
Great. So ready for the next question?
Yep, let's do it.
So everybody, your devices, I hope, are ready. Four more,
yeah.
The 10 seconds.
Mm-hmm.
Okay, let's move on.
All right.
Oh, there's some movement. Some movement. That's awesome. Okay, go back to your slide.
Yeah, go back to, I just want to mention another project as well that I've used before in the past, which is the Falco project. That's something that it was started a few years ago by Sysdig, and they used to call this behavioral security. So this is basically like you have a bunch of rules, and whenever there is some activity in your container, this is not just for containers, also for instances, but you can use this for containers. So whenever there's some activities in your containers, like for example, if someone went inside the container and tried to run commands, something like that, you can be alerted when these things happen, right? So that's another good project as well they could take a look at for security of containers.
Yeah, CNCF project, I believe.
CNCF, exactly. Yeah. All right, so this one was task number 3. Task number 4 now. Okay, so task number 4, we're gonna build the backend and run it. And this task number 4 is a little bit trickier than the previous one because we're going to learn something which is called multi-stage build. So I'm going to go back to AWS. And let's go back to the backend one. So this is the Docker file for the backend. And before we start coding, there is something that we need to talk about, which is the bridge network. And I'm not gonna go too deep into the concept because there's a lot that we can talk about. But basically, you have the host network, right? So if you're running, for example, whenever you run a process here, you can just access that process using localhost pretty much. But when it comes to bridge network, so basically Docker creates I guess we can call it like a virtual network in your instance, which has a different IP address, the sort of things. Usually is not accessible outside the instance because, for example, this instance is 10 dot, but the Docker network is usually 172, right? So it's a completely separate thing. So what we need to do here is create a Docker network for the backend. To do that, we do Docker network create and then give the name of the network, so backend. And if I do Docker network list, these are all of the networks that I have. You see some of them already come with Docker. So like, for example, bridge, and then host and none. Yeah, so this is if you want to use a bridge mode, or this is for host. And this is actually the one that comes by default. And if you don't specify any network, that's where Docker is going to run your container. But for this challenge, we're going to create our own network. Okay, so I created the backend. Now let's go back to the Docker file in Cloud9 so we can develop it. So this one is a bigger one, right? So first, we know that we're going to have 2 from statements, yeah. And both of them are going to use Alpine. Then we're going to have to pull the backend from GitHub first. We're going to run npm install, and then we're going to go to the second stage. Okay, so let's just go over it. There's a lot of requirements here. So first thing is to do a from. Is from. So that's going to be Alpine 3.12, and I'm going to put something here. I'll explain later what that is. Okay, so we're going to start from Alpine 3.12, and then we're just going to run a command, which is to install Git. So this one doesn't come with Git by default. So we're going to install Git. And then I'm going to run a couple of other commands with the same run. And this is actually a very good doc tipper. So tip. So if you do multiple runs, this is going to create multiple layers, right? Which means that your image could potentially be a little bit bigger. So if you want to shrink a little bit your image, you can have a single run instruction, and then that means it's going to be a single layer. When it comes to Docker and layers, it can get a little bit complex, but that's basically what it is. First, we're going to install Git, and then I want to create a folder called /code. So mkdir -p/code. And following that, I'm just gonna cd into it. And then I'm gonna clone the repo. So the repo is this. So clone this. And I believe that's everything we need. Okay, so we just clone it. And then now we're gonna go to the second part. So the second part, there's another from, also Alpine 3.12. And okay, so the first thing we need to do is make sure that Node.js and npm are installed. Remember that for the front end, we use the node carbon image, which means that node was already installed. But this one, I want to use a smaller image. So Alpine is usually around like 4 megabytes or something like that. So I'm going to use a smaller image, but that means I need to install Node.js myself, right? So that's basically the difference. So it's up to you if you want to use a specific image or if you want to start from like kind of scratch, let's say, and install everything. So for this, just so we can learn something different, we're going to install Node.js. Command to install is apk add. That. And then after this, so this is the tricky part. So now we need to copy the backend that we cloned from the first stage, which is this one here, to the second one. Yeah. And one of the reasons why we usually do multi-stage is, for example, for the first one, I need to clone a repo, which means I need to have Git installed. But think about when you run your application. Do you need Git? Probably not. So you don't need Git to be installed in your system. And that's why we do multi-stage. So the first stage here, we have tools that are necessary to build, do whatever you need to do. But then when it comes to running our application, if we don't need those tools, that means we can do another stage, right? So in this second stage, I'm not going to have Git installed because I don't need Git. But the thing about this is that we cloned in the first stage. That means we need to copy everything over to the second stage. And this is just so you can learn how to copy from stage to stage. So we're going to use the command called copy, which we used before as well. But now the difference is that we need to tell Docker where to get the code from. And the keyword here is from. So there is something which is -- from, lowercase. So -- from. And then the value for the from, it can either be an alias, which is, so for example, here at the top, we've got s git clone. So this means that git clone is an alias for the first stage. So I can either specify from git clone like that, or I can use an index. So the stages, they have indexes, and the first one is 0. So if I do from 0, that means from the first one. Or I can just use the alias like that. So we're gonna copy from the first stage, and when we copy from the first stage, we need to tell where our code is gonna be in. So notice that I created a folder called /code, and inside that /code, I did the clone. Yeah. So that means that the source folder in the first stage is /code / and then the name of the repo, which is all this. And then after that, the second one is a destination folder, which is going to be in the second stage. So I'm just going to call it /code as well. Doesn't really matter what's the name of the folder. And okay, after that, again, remember the work directory. So every time we run the container or we go inside the container, my starting point, I want it to be /code. So that's why I'm going to do work dir /code. And now that we're there, we can run npm install again. We need to make sure that we have everything installed. And then finally, all uppercase, cmd. Let's go back and, so this is the command that we need to run. So npm run server dev. Again, just remember that it cannot be in single quote. We need to split this. So this is the command. This is the first argument. And this is the second argument. Okay, so I believe that's it for the file. So now we can just run, make sure everything is okay. All right. So back here, so back to Cloud9, need to go to Backend, and I'm just gonna cat Dockerfile. We're saved. Yep, everything's there. Let's try to build them. Build -t. And I could just call it --be, and then I retag, but I'm just going to call it directly with my DockerHub username. So the Dojo series /dd-be. And remember, you need to specify where the Docker file is. So dot. Build that. Come back here. So after you build the image, let's run. All right, so let's just wait for that. Nancy, were there any more questions?
Let me look. No, just good comments. This is so helpful. Thanks. So, nice. Yeah. Cool. I've been very happy with the feedback on how, they say usually in CTF they get frustrated and don't learn as much as they did in this one, right? So that's been really nice to hear. We even had a teacher saying, oh, I'm going to try this in my class because this is a really good way to teach my student how to use technology. So yeah,
Oh,
it's
that's
been fun
nice.
to hear. Yeah, good
Super
on
cool.
you.
Nice. Yeah, I think it's, you need to feel like you're progressing, right? So if you're like stuck and then like hints don't help you and you just, end up give up, right? So yeah. Okay. So we're nearly there. And what should happen after we run is we're going to see another message, which here is redacted. And that's going to be our flag. Yeah, those who develop in Node.js know that NPM sometimes can take a while. All right, so it's all good. Now let's try to run it. So Docker run, make sure I have everything here. Docker run, and then this. All right, so we got the error that we expected. And yeah, I see that some people were getting this little error, NA or ENOSPC. I honestly didn't run into it when I was running this for multiple times, but that's something that I'll definitely take a look at to investigate how this can happen. But my advice right now is maybe try to build in your local machine if it's not working on Cloud9. Could be something Cloud9 is not allowing us to do that. So maybe try in your local machine, push to DockerHub, and then you can run in the Docker host. All right. So this is the error that we got, and I believe this is going to be the flag, which is Mongo network error. All right, let's try to submit that. So DevSlop, uppercase S, CTF. Okay, let's see. All right, so that was the flag for test number 4. Let's do our little quiz now.
Second. So next question. Here we go.
All right, this should be a quick one as well.
Another 5 seconds.
Yep.
Let's go.
Okay.
How's the leaderboard looking? And May still staying on top.
Still holding there.
yeah, holding up.
Well done.
Awesome. Okay, back to you.
Cool. Yeah, and just to answer that one, so basically when you have -- from, it needs to be either the alias or the number 0 if it's coming from the first one. There is one option which was from Alpine 3.12, and if you do that, that means it's gonna grab a fresh Alpine, and yeah, that wouldn't work. All right, task number 5 now. So let's run the backend in the correct network, because remember when I mentioned if you just run a container, that's going to run in the default bridge network, but we want to run in the one that we actually created. So before we do anything, before we can run the backend, we need to push it to DockerHub. So let's do that. So this is the Cloud9, and then I'm going to bring it again. You can do a push. Yeah, I just saw Amy's comment that yeah, she didn't get that error. I think it was probably like 2 or 3 teams that got that error. Honestly, that's why like it's very weird. It's not something that is happening all the time. Must be something, some small detail. But I'll do some investigation on that. I'm curious to know what it is. Okay, let's go back to here. No, not here, actually, here. So make sure that it's there. Yep, it's pushed. So I can just basically run that. Let me see if there's some option I need to do. Yeah, so the option that we need to be careful with is -net. So that's how we specify where we want the container to run, in which network. So I'm gonna do Docker run. And also notice that if I do Docker images, my backend is not there, but I don't have to do a pull. I can just do Docker run. Docker's gonna take care of that for me. Let's run in detached mode, which is being background. Then -net equals backend, and then the name of the image. So let me just make sure I copied correctly. I'm gonna copy from here. And there it is. Sorry, let's do that. See, so it's downloaded for me, even though it's not there. Oh, so someone got the error running locally. So that could be a Docker thing. Maybe not necessarily an AWS or Cloud9 thing then. Okay, good to know. All right, Docker PS, we can see that our backend is running. Let's see what we need to do next. Actually, let me just do a logs. We're still getting the same error, which is good. What we need to do now is to obtain the flag. We need to do we need to inspect the container and get the IP address of that container. To do that, we first need to obtain the container ID. So Docker PS backend is right here at the top. So just copy that, and we can do Docker inspect. So inspect is a command to inspect containers, inspect networks, images. You can inspect a lot of things, not just containers. So copy that, and we get a huge JSON object with a lot of information about the container. But what we're looking for is the IP address, which is this one right here. And what we need to do is, so there is a tool called JQ. So if I do pipe JQ, that's going to return a JSON in a little prettier format. And so what we're going to do is we're going to filter, right? We're going to pass a filter to JQ so we can obtain the IP address. And the flag is going to be that filter. So if I do JQ, and then there is an option called -r that I use a lot. So if you don't use -r with JQ, the answer or the value is going to be with quotes. If you don't need quotes, like you have like an automated, some automated system, you can do -r. That's going to remove the quotes for you. All right. So first thing JQ is, let's take a look at the top. So at the top we have an array, I believe. Yeah. So we have an array. We have curly brackets. And first thing is to do a dot, right? So we're talking about this object. And then we need to select the item in this array. So the item, there is only one, so which means that I need to specify 0 indexes start at 0. So it's going to be .0. And then after that, let's take a look at the next key. So we're just basically going to specify keys separated by dots. So taking a look at the first item here, we're going to scroll down and find network settings. Scroll down a little bit more, graph driver, and there we go. So we've got network settings. So that's the next key that we're looking for. So network settings. And then after that, what comes next is networks. Yeah, so after network settings, we have networks. So networks, and then backend. So that's the name of the network. Backend, and then finally the IP address. I remember some people were trying to, they were able to get the IP address with less keys, but the goal here is just to use as many keys as you could until you get to the IP address, right? So that's why some people were they're saying, oh, the flag is not correct. It's just because you need to specify every single key up to the IP address. If I do that, notice that there's no quote around the IP address. If I remove -r, there is a quote, so that's why we use -r from time to time. Yeah, all right, so this is basically the flag. So this is the filter for JQ. Let me copy that. Back here. And so DevSlop CTF. Okay, hopefully everything's correct. All right, there you go. That's the flag. Quiz time. Let's do it. Test number 5. Let's see.
Here we go. Next question. Keep forgetting your name. Okay, it's coming. Slower to come in. Let's go.
Yeah, it's going to be a bit tricky. Yeah, the answer to this one I didn't mention. So it's going to be anyone's game.
Making it tough. Winner's going to deserve it. Okay, another 10 seconds. Okay, I'm moving on. Number 18. Nope. Let's go. Oh, just in time.
Let's see.
May still there. Broco holding on. Wait, how many? 1, 2. Yeah. 6 got it right. So it was pretty divided.
Yep. Cool. Yeah. So for this one, basically, so when we say container ID and we want the same output, that means we're looking to inspect a container, right? So if you try to specify an image, that's gonna inspect the image, so that's not gonna work. If you try to specify the network name, that's gonna inspect the network instead of the container. For this one is actually the host name, because whenever you run the container the same way that I ran, the host name of the container is actually the container ID. So that's pretty much the same thing. So if you use the host name, which is the container ID, you're gonna get the same output. So yes, this one was a little bit tricky.
So back to your slides.
Yep. Tab number 6 now. Starting at the database. All right. So for the database, we're gonna do the same thing. We're gonna create a separate network for the database. So let's go back to our EC2 instance. We're gonna do Docker network create DB. So that's gonna be the name. And if I do network list, we see it there, right here, and it's of driver bridge. And after that, we need to create a Docker file for the database. This Docker file is going to be a little bit simpler when compared to, for example, the backend. So coming back to Cloud9, Docker file. So what we need here is, there are a couple of things which are different. So first thing is the image, which is not Alpine 3.12, is 3.9. So we're going to do a from Alpine 3.9 and see what else we have. So we need to run the command ap add. So this is to install MongoDB in that image. MongoDB is going to be our database. So I'm going to run that. And then after that, so whenever you run, that's going to install MongoDB and you're ready to run it. So to run something in a container, you have cmd. And then we're going to do the following. Coming back to the challenge, you see MongoD --bind all --bind IP all. Let me explain what that is. And let me split. Okay. Now, if I run MongoD without any arguments or any parameters at the end, like this, what's going to happen is that Mongo is going to run fine, but it's going to bind to localhost, right? And when I say bind to localhost, that means that every time you try to connect to the database, you can only do from within that container. Yeah. So the traffic needs to come from the loopback interface, which is localhost. If you want the database to be accessible from different Docker networks, you need to either bind to that Docker network address, or if you specify bind IP all, that's going to be 0000, which means any network, any IP address is able to connect to your database. So when it comes to security, it's good to lock it down as much as you can. So you can either specify the IP of a certain Docker network, or if it's gonna be something running like as a sidecar in the same network stack, you can just remove bind, and that's gonna be just listening on the loopback interface. So yeah, so we're gonna do MongoD and then bind IP all. I believe that's everything we need. And we're ready to build, push, and then run it. So let's do everything now. So go back to Cloud9, database. So everything's there. So let's do docker build -t series dash dot at the end. All right, and then push. And when we run, we're gonna run in foreground mode. So I'm not gonna specify -d because I wanna be able to see something here. And we're gonna specify -net. So that's the network database, or the database network. All right, so it's pushed to DockerHub. Going back here, I can do docker run -net db, and then the name. Okay, it's downloading. Let's see what's gonna happen. All right, so we see that it's shutting down. If we scroll a little bit up, where is that? Oh, there you go. Yeah, so non-existent path directory /data/db. So for MongoDB, by default, it expects a folder called, or a path /data/db, which is non-existent in that container because I didn't run like a mkdir here. There's nothing there. What we need to do is to use volumes. Yeah, so that's something that it's very important when it comes to sharing data between the host and the container. So Docker basically had they have right now three volumes types for when we're talking about Linux. First one is just like a regular volume. The other one is something called bind mounts, and the other one is tempfs mounts. All right. So tempfs is not going to be used here because this is for memory only. This is not going to be, files are not going to be written to the file system. So it's either going to be volumes or bind mounts. So let's take a look at the difference here. So let me open this quickly. Storage overview. And all right, so for volumes, so these are stored in part of the host file system, which is managed by Docker. Yeah. So with what this means is that whenever you create a volume with Docker using Docker volume create, etc., that's going to allocate a folder in the system. You don't know what that folder is, and that's going to be managed by Docker. And in theory, like it says here, non-Docker processes should not modify this path or this part of the file system. And the good thing about this is that you don't know where it is. You just know that it's somewhere in your system, and you can safely just share with the container. And whatever you create inside that container, you know that it's going to show up in the host. Now with the bind mounts, it's very similar, but this is actually the way we used to do before, which is you create a folder in your file system, which means you know what folder is that. and you share that folder, right? And in this case, non-Docker processes on the Docker host can modify them because you know where it is, right? So sometimes we create a folder in the home directory and we just share there. So if you do that, if you know the folder, that's a bind now. If you let Docker manage, that's something which is just called a volume. And that's what we're going to be using for the database. Yeah, so we want Docker to manage everything for us. The Docker volume create first. Let me list. There's nothing here. Haven't created anything yet. So Docker volume create, and the name is going to be db-vol, I think is the name. Double check. Yep, db-vol. Okay. Let's create that. If I do list again, we can see it there. And after that, we just need to run the database one more time and specify the new volume. So we're gonna learn a new option now. Now, if I run around the database, let me pull it up again, the command. There are a couple of ways. There is a -- mount that you could use, but we're gonna use -v, which is, I think is a little bit simpler, right? So with the -v, what you're gonna be doing is you first is gonna specify the name of your Docker volume, colon, and the path inside the container. So the name of the volume in my case is db-vol, colon, and then inside the container, what's the folder that I want to create is /data/db, /data/db. And there is you can specify a third option here, which is whether you want this to be read-only or read and write, right? So you can specify here, but I'm just gonna leave it empty for now. And just before I run this, just remember one thing that it's important to mention. So let me just make this a comment. If I do a Docker volume list, I can grab this name and do Docker inspect db-vol. When you do Docker inspect in a volume, that's where you can see where's the mount point, which means what folder in my system is being managed by Docker. If I grab this, and it's under var, so I need to use sudo. So ls, there is nothing there, completely empty. But the idea is that whenever you run a container and you share this volume, as Mongo it starts writing, there's going to be a bunch of files there inside the container. And because we're mounting this folder in the host into the container, all the files are going to be kind of like sent back to the host. So we're going to be able to see here, essentially. So, all right, so everything's empty here. This folder is empty. Now let's run this command. So in the db network, specifying that volume. And we see that waiting for connections on port, which means Mongo is running. Yeah. And if I kill this and I do ls, we see that we've got a bunch of things there, and that was created by the container because we mounted that path. All right, so what we need now is, okay, for capturing the flag, we need to inspect the container, which we've done before, the volume, and we need to find a file inside that volume. So going back there should be a file with the extension bson, which is this one here, which is a binary encoded JSON version for MongoDB to keep track of collections and sort of things. And the name of the flag is something.bson, which in the case is storage. So storage is our flag for this task. DevSlop, CTF, storage, edit. All right. A little question now about this one.
So next question, number 6. Oh, it's taking longer to come in.
Yep.
Okay.
There's a bit of reading for this one.
Got worried there.
Maybe a few seconds more.
Another 5.
Yep.
Let's go.
That's it.
Okay. Always hoping somebody like 16 comes in. Okay. Let's do it.
All right. Let's see.
What happens?
Leaderboard.
May holding out Barco. How many do we have? 1, 2, 3, 4, 5. I think 5 again, and it's on the top. Okay.
All right. So the answer for this one. So basically, like I mentioned, so Mongo, if you don't specify any option, so it's gonna bind to the loopback interface, so localhost. So it's gonna accept connections coming from the same container, right? Because it's gonna be running on localhost, and also it's a little bit tricky as well. So if you run Docker and you expose a port to the host, right? When you try to access the database or MongoDB in this case, you can access 127.0.0.1 and then the port that is being allocated to the host. And because you're going through 127.0.0.1, which is also the loopback interface, so the container is going to accept that. So so MongoDB will also accept connections coming from the same Docker host if you access the database using 127.0.0.1. Oh yeah, did notice that we had to select 2. Yeah, for this one it was 2 2 options. Yeah, so we're always gonna say either select 1 or more options.
Good.
All right, should we go to task 7 now? Okay, so for task 7, we're gonna connect the backend to the database, right? And let me go back here. Let me run the database with -d. If I do log, just waiting for connection, okay? And then, all right, so basically what's happening here. So the first step is going to be to pass an environment variable to the backend application. And the reason why we're going to have to do that is if you look it down here, this portion of code, this is the code for the backend. And when you have process.env.mongodb host, this is an environment variable in the system. So our Node.js process or Node.js application, the backend, is expecting an environment variable called MongoDB_host. And if we don't specify anything, that's why you're going to see undefined, right? So the variable is undefined, and that's why the backend is not going to be able to communicate with MongoDB. So what we need to do is rerun the backend, specifying the MongoDB host. First, we need to obtain the IP address of MongoDB. So to obtain that, we can grab, so this is the DB, we can inspect, and this is the IP address that we have, so 172.19.02. And first I'm just gonna stop the backend, and I'm gonna run it again, passing an environment variable. So docker stop, docker remove, and it's not running. So if I do docker ps, okay. Now what we can do is, let me just bring up the history. The backend. Yeah, so this is the command that we're going to be running. But then we're going to specify, so -d detached mode. The network is going to be backend. And then now if you want to specify an environment variable, there is an option called -e for environment variable. And the syntax is you first specify the environment variable. So in this case is MongoDB_host equal, and then specify the IP address, which is 172.19.02. So now when I run the backend, this is going to be used in the code to access the database or the MongoDB in this IP address. So let me run this. I'm going to do logs f. So it's going to take a little bit because it's trying to connect to the database. But after a few seconds, we should see a message. Yep. And the message, now it's something different. So before, we would see undefined, right? So no environment variable. Now that we provided the environment variable, we have 172.19.0.2. Yeah, so we know that it's trying to connect to the IP address, but it's still not working, and that's what we're going to solve in the next task. But for this task, what we need in terms of flag is the portion of code here that says on first connect, redacted. So going back here, we have on first connect, and this is supposed to be the flag. So this is the name of the error, Mongo network timeout error. DevSlop CTF. All right, so task 7 is done. Let's have our question.
Let's go. Next question.
Yeah, and be careful, this one is select one or more options.
So we're not even saying how many, but it's more than,
Yeah.
maybe one, more than one.
Could be one, but yeah. All right, I've got the first one.
Those are 5 seconds.
Yep.
Oh.
Got more coming.
Okay, I'm moving on.
Let's do it.
How did we do? Ooh. Oh, it moved.
A lot
It
of
moved.
changes.
Okay,
right.
go ahead.
Yeah, it's a good one. So basically, all right, so how can container B communicate with A? So first of all, internal IP address, right? So that would work fine. Now there are two options which can be a little bit confusing. So the container's name, yeah? So there are two options. Either you define the name with -- name or not. Let me go back to my screen. I'll just quickly show one thing so everyone knows what this means. If I do a Docker PS, the last column of Docker PS is a name. If you don't specify, when you do Docker run, you don't specify -- name, it's gonna be like a completely random name here, yeah? Now, if you try to access the container using this completely random name, that's not gonna work. But if you do a Docker run, and then you specify -- name, and you call it the container something, then you can use that name to communicate, right, between the containers. So the correct option would be the name when defined with -- name. And then the last one is using the container ID. So you can easily use the container ID, and the container ID is going to be a DNS name in the Docker network. All right, cool. Let's go back now. Task number 8. That's the 15,000 points task. That's the fun one. All right, now what we're going to do. So we saw that the backend, even though it has the IP address of the database, they weren't able to communicate. And the reason why that happened is because whenever you create a Docker network, so we have the default. Sorry, there is a question, right? So who comes up with name? I don't know if anyone knows, but I honestly don't know if there's some algorithm coming up with random names. But sometimes there's some pretty funny stuff there if you don't specify your own name. Yeah. All right. So yeah, when you create a network in Docker, by default, they cannot communicate with each other, right? So you have user-defined bridge networks, and you have the default bridge network. When you have two user-defined bridge networks, they cannot communicate with each other. And that's why we're just, kind of like messing up, let's say, with the IP tables. You wouldn't necessarily do it exactly like this, right, in production environment, but this is just to show you, something else, right? So how you can interact with IP tables to make networks communicate. So first thing we're going to do is to run, just to list all of the rules that we have in the IP tables with this command. And I'm not going to go, into IP tables, but basically there are two, there's a bunch of chains here. One of them is Docker, and then you've got Docker isolation stage 1 and Docker isolation stage 2, right? And the request goes through, through these chains. And so at some point, it's going to get to Docker isolation staging 1, and then you see that the target is Docker isolation staging 2. That's the one that we care about here. If we take a look at Docker isolation staging 2, we have 3 drop rules, right? Which means that if the traffic is going out from this interface, it's going to be dropped. If the traffic is going out from this interface, it's going to be dropped, right? So that's how we're kind of like isolating the Docker networks. And if you want to take a look at these networks, you do efconfig, and there's going to be a bunch of interfaces. But at the top, there are going to be 2 of them, these 2, and these are the ones that we created. So 172.18, that's the backend, and 172.19, that's the database. So what we need to do here is we need to create a rule in our IP table that it's gonna allow traffic to go from the backend network to the database network. Okay, and what we do is we create another rule, and that rule is gonna be on top of the drop rule, right? So we create an accept rule that's gonna be on top of the drop rule. So that's gonna have higher priority. So to do that, there is a bit of a lengthy command. So sudo IP tables. First thing, we need to specify the interface, right? So the interface is gonna, not the interface, the chain. So dash uppercase I, that's gonna be the chain. And the chain, if I go back here, is Docker isolation stage 2. So that's the chain that I want to add rules into. Dash I chain. And then dash I, so that's the, I'll come back here. You've got in and out. So dash I is for in. So what I'm going to do is I'm going to do from backend to database, and then from database to backend. So I have to have 2 rules, right? So the traffic goes back and forth. So I'm going to grab the first one. So this is the backend, and then out is going to be database. And finally, we need to say if the target is drop, accept, etc. So dash J, lowercase, and then all uppercase, accept. If I bring IP tables again, so we have accept here at the top. So from this interface to this, the traffic will be accepted. Now let's do the all the way around. This is going to become in. This is going to become out. Okay, and there we go. So from one to the other, from the other to the first one. So that these are the 2 rules that we had to add to our IP table. And what else here do I need? I think that's it. Yeah, so now that the rules are there, we can go to the back end and make sure that it can connect to the database. So to do that, what we need to do is we grab the ID of the backend container and run exec. Oops, let me go back, run exec. And then from there, we're gonna install okay, let's go back. So we're gonna install telnet, Docker PS. Let's grab the backend first. So this is the backend. Docker exec IT. This is to go into the container and bring up the shell. All right, so this is the backend container. Let's add. Yeah, and notice that this is, this is the container is running here, right? So I'm not launching a new one. I'm just going inside the one that is running. So let me install telnet via that package. And then I can do telnet, IP address of the database, 27017. Telnet, 172.19.0.0.2, I believe, 27017. Yep, there you go. So it says connected. That means now that we have our IP tables rules in place, the backend can connect to the database. Perfect. So that was it. That's everything we had to do for this one. Let's exit. And then, okay, now capturing the flag. To capture the flag, what we're going to do is we're going to run TCP dump in the database network interface. So we want to listen to all of the traffic coming to the database one. But before we do that, there's one thing I wanted to mention. So let me copy. Oh wait, actually, let me grab let me exit the container. ifconfig. This is so 19. Let me copy and paste this here, and then first -i. And all these options. I run this. You see that nothing's happening, and I don't know if anyone had this problem during the event, but this was I guess was part of the challenge as well, to kind of like figure it out why this is happening. But basically, what's happening here is that the backend is not sending anything because it tried once, it didn't connect, and later on we included the rules, and now there is a route from the backend to the database network, but the backend is just like it's saying whatever. I'm not gonna try, right? So what we're gonna do is just rerun the backend container so it starts communicating with the database again. So let me kill this. Stop. Move. And let's see if I still have in history. That was the last one that I ran. Again. And Docker. Yeah. Now it says connected to MongoDB. So we know that at least a little bit of traffic was sent to that database network interface. Now let's run it again. TCP dump. Now we see something completely different. So this is the data coming from the backend. What we're interested in for the flag. So let's take a look at the flag. We need to take a look at this line specifically from that traffic. So we've got version, and which is this one here, right? So let's take a look at this line. So what do we need? So the flag is the first 2 octets, no space, of the hexadecimal representation reading from right to left. I know that there was a little bit of confusion about this right to left, and I even mentioned to the person that's something we're gonna keep in mind for the next one to try to explain a little bit better. But what we meant from right to left is like reading from right to left, and we're gonna read the chunks, right? So it's, for example, if we're reading from right to left, it's not that it's gonna be 1656. It's still gonna be 6561, but we're just gonna we're reading the chunks from right to left. Okay, so we need 2 octets. Now that's the catch. So 1 octet is 8 bits. 2 of them is 16 bits in total. This thing here is an hexadecimal representation of the data, and 1 hexadecimal character has 4 bits. So if you take 16 divided by 4, that's gonna give you 4 characters, which means that 16 bits, that translates to 4 hexadecimal characters. And if you're reading from right to left and you want the first occurrence, right, or the first 2 octets, that will be the first 4 characters, 6561. So that was the answer for this one. So that was the flag. Back here, so DevSlop, TF. There it is. All right, question time.
Let's do it. Next question. I was waiting. That was a nasty flag, eh? Because
was,
even
yeah.
if you had the correct answer, you could waste a lot of time just trying to submit it.
Yeah, and I know some people were trying. I think they thought 2 octets would be 2 chunks, right, of the hexadecimal. But yeah,
Yep.
that's actually double of the value we're looking for.
Another 10 seconds, folks. Should I go? Oh, one more. The 5. Okay, I'm going.
This is like this is totally a random comment, but I'll make it. It's like when I'm doing popcorn. I wait like 3 seconds so I don't hear any pop, and then I know it's done. Same thing here.
We're watching for the pops.
Yeah. All right.
All
2
right,
moves. Cool.
let's go.
Yeah. So basically, this one. So like I said, hexadecimal is 4 bits, and we've got 5 characters. So 5 times 4. That's that's 20.
Here we go. Keep going.
Right. And just to highlight a comment from Amy, it says that love that you incorporated TCP dump. Didn't get that far, but sweet. Yeah. So I guess my intention here is that there are people that they think that I'm gonna learn Docker and that's gonna be enough for everything. But reality is that Docker is kind of like just one thing, right? So whenever you run a container, there's so many things happening in the system. So I think it's important for you to have an idea, what's actually going on behind the scenes. I guess that's why I got inspired and included a TCP dump. All right, task number 9. So we're nearly there. Now we're going to connect the backend to the database, which pretty much we've done already, right? Yeah, so the result of this, we should see connected to MongoDB, which I believe it's already there. So let me double check. So Docker PS, backend, logs. Yeah, it's connected to MongoDB. So we're actually done. Now let's work on the flag. Okay, so for the flag, we're going to copy the ID of the database container, do a Docker logs, and we're going to look for versions there. PS and database, this one, and logs. Let me open this up a little bit. What we're looking for here. So we have connection accepted from one connection and then received client metadata. So we have connection now open and then receive client metadata. All right. We're going to see versions, and usually versions, there is something called semantic versioning, which is this format. So we've got major, minor, and patch. I'm not going to explain what it is because that's coming on the next question. But the flag for this is get the major number of each one of the versions, which is the first component of the version. And we're just going to multiply them. All right. So the first version that shows up here is 3.63. So 3 is the major. So 3 times, the next one is this version, 3 times 4, that's 12. And then the third one is this one here. In 12 is the major, so 12 times 12, 144. So that's the flag for this task. Okay.
Ready for the question?
Let's do it.
Almost there. Almost there.
Yeah, this one is multiple choice as well.
Select one or more options, people.
Yep.
Oh, People are going for accuracy. They're slower.
This one is a bit slower, right?
Let's give them a bit more time.
Yep. Maybe 10 more seconds.
Are you good to go?
Yep, let's do it.
Let's do it. All done.
All right.
Okay, still the same two on top.
Yep.
Have one more questions to see who wins this.
Yeah.
Oh.
Yeah.
I removed your screen. Let's go.
All right. Yeah. So I just want to quickly show this website. If you haven't heard of semantic versioning, this is a 2.00. And here it's going to explain exactly what's a major, minor, patch, right? So major is for when you make incompatible API changes. Minor is when you add functionality in backwards compatible manner. And the patch is the version where you make a backwards compatible bug fixes only. Yeah. There's more to it, right? So you can read, there's way more to it here at the bottom, but that's basically what it is. All right, and the website is semver.org. All right, let's go back to the challenge, task 10. So that's the last one. Okay, basically now it's cherry on the cake, just connecting the front end to the back end. And to do that, we're gonna have to go back to the front end Docker file. And you see that this is the portion of code that contains the API URL for the backend. And there is a kind of a placeholder here, right? So like backend_IP. And that's actually what we saw in one of the first tasks. So we're going to have to put an IP address here. Now, there is a requirement from the challenge, which is we're not supposed to go into the code and hard code. We're going to have to specify that through Dockerfile. So let's see how we can do that. So for the last one, going back to here, let me pull it back. So front end Dockerfile. All right, now everything here is going to be pretty much the same apart from run. For run, what we're going to do is we need to replace backend_IP with an IP address. If you're using Linux, I guess one of the easiest way to do that is using sed, right? The command line. So what we're going to do is sed-i and then s//g. And here we're gonna put the what's currently there, which is _backend_IP __. And then after the slash is what's gonna replace that placeholder. And this needs to be the IP address of the backend. Okay. Now, two things. I could hard code here the IP address, right? But this is something that could change potentially. So what I'm going to do is we're going to learn something which is called an argument for the build. First, I'm going to obtain the IP address. So let me go back to this EC2 instance, and I can do curl ifconfig. I don't know if anyone had that during the challenge, but if you grab the IP address of Cloud9, that would be wrong, right? Because the database, the backend is actually running in the Docker host, which is a separate EC2 instance. So you need to grab this IP address. Going back here, I'm gonna create an environment variable, which is actually is an argument for Docker, but it looks like an environment variable. And I'm gonna call it backend IP. It could be anything, right? But I'm just gonna call it backend IP. And then after that, we need to specify the path for the file. Now the path, we need to be careful with one thing. If you clone the repo, there's going to be a folder called front end. But because I copied everything inside front end to /code, well, we don't have the folder front end. We have source, from source onwards, right? So what I'm going to have to do is to copy from source all the way to the end, and then come back here and put it at the end. And I need to, actually, instead of do 2 runs, I'm gonna do this. I'm gonna run another sad command. So same thing, but it's a different path. Just grab that path. So it's gonna be source all the way to the end. Right? And then npm install, I'm just gonna kind of merge it here. So we're going to execute 3 commands in 1 run instructions. Okay. All right. Now, one more thing we need to do is at the top, there is an instruction called uppercase arg. So that's for argument. And I'm going to call it backend underscore IP. So basically, when we're building the container, I can specify different values for the backend IP, and that, so that way I don't have to hard code it here in my Docker file. So that's why I have this arg at the top. So that's one of the ways of doing this. If you hard code it, not a problem, but I just wanted to show you how you can use arguments. Right, if I didn't miss anything, I think that's everything we need. Now let's see how we can actually build this. Let me make sure that I am in front end. Okay, so I've got everything there. Now, when I do Docker build, there is an option called build-arg. Oops, build-arg. And this is how I specify the argument. So the first, I need to specify the argument, which is backend underscore IP. And then I do equal, and then I paste the Docker host IP address, which was this one here. So 3.something. Here, and that's how you specify the argument for your Docker file. And then after that, same thing. So -t, which is the tag, do series fe, and then dot at the end. It's a little bit bigger command, but at least we don't have to hard code it. Okay, npm install. Let's see what else. I think that's the last thing, and then the final test. Yeah, so what I mentioned before is that if you grab the IP address from Cloud9, the front end won't be able to talk to the backend, right? Because the backend is not running here. So that's something people had to be aware of. Okay, I think it's nearly done. There you go. Before I push this, I just want to make sure that everything's correct. So I'm gonna do docker run -it of the shell, and I'm just gonna get this file. If I go all the way to the top, yep, there you go, 3.2.18. So that's the IP address. Okay, so it should work. Let me exit. Now I can push. Well, there's one thing we're gonna have to be careful, but let me just wait until this pushes, and we'll talk about it. Yeah, so just saying the comment about the GitHub. Yeah, so everything is published in my GitHub account, so you can access that at any time. It's gonna be there forever. Awesome. So everything is already pushed. Coming back to the instance. Now, one thing is about Docker is that Docker loves to cache stuff, right? So it's gonna cache as many layers as it can. I'm gonna try one thing, and it might not work, and I'll explain why that's happening. So when I pushed my image, I pushed with the tag latest, right? Because I didn't specify anything at the end, so that's gonna be latest. If I do Docker images here, oh, it's already here, latest. So what do you think is gonna happen? You think Docker is gonna download again, or just gonna use this? Let's see what's gonna happen. So first I'm gonna remove the container, which is this. Up. And I don't remember the whole thing, so let me just grab it. Type 1. That. Okay. Now if I do exec, go into it, let me try to cat that file. Yeah, see, it's still backend IP, which is not what I had in my Cloud9 instance. And yeah, the problem here is that I pushed an image which is called latest, but latest is already here. So for Docker, it's like, well, it's already in the system, so I can just use it, right? And that's one of the issues of also using like the same tag all the time, because one, you don't know what code version is there, and second, Docker already has it. So it's, unless you tell it to actually pull it, it's not gonna pull it. It's just gonna use what's in here. So what I'm going to do is I'm going to remove this from my machine, from the Docker host. And if you want to remove an image, get rid of the image, is Docker mi. Actually, before I do that, it's not going to allow because the container is running. If the container is running, it's not going to allow you to delete the image. So let's stop the container first. So Docker stop, Docker remove. Now that it's gone, I can do images and RMI, so remove image, and then specify that. Okay, so you see a bunch of things, and all these things that you see here are the layers, right? So Docker build images, using layers, right? So for example, if I have the Docker image, here I don't have, but let's say that I had Alpine already downloaded, yeah? And I want to build an image which is based on the Alpine image. Docker is not going to download Alpine again because Alpine is already in the system. So, all these images, they have different layers, and Docker is just going to try to reuse as much layers as he can. That's why you're going to see, stuff like this. It's like, oh, I'm deleting one image, but, there's a bunch of things being deleted. So these are all the multiple layers of your image. Okay, so it's gone. Now let's try to run again. Out of my system. So if I run the same command, it should pull. And hopefully it's the latest version. And yeah, that's another thing which is, it's a good practice if you use a different tag, for example, a commit hash, because Docker will always be pulling because the tag is different. Yeah. And there was I had this experience where we had the tag latest in the repo, and that was being used in production. And some errors in the CI/CD system. Someone pushed a tag, a new image with a different code with the version latest, and everything broke. So yeah, so be careful when using latest. Okay, Docker PS, we got a front end here. Docker logs compiled successfully. Let's go into it, see if our IP address is there. That. And there it is. Now we have the IP address. So yeah, I had to remove the image and then bring it up again. Yeah, it can be very painful, so be careful with that. All right, I think everything's fine now. We have the IP address of the backend, and if I do Docker PS, let's make sure of a few things. Yeah, so we see that the front end is exposed in port 8080, but remember that the front end is going to be loaded into your web browser, your local machine, and it's going to do a request to the backend via the internet. Now, since the traffic is coming from outside, the backend also needs to expose its port. Otherwise, the front end is not going to be able to communicate with it, which means that we're going to have to rerun the backend and expose the port. Going to be this command plus the port -p 7777. Make sure that it's connecting to Mongo still. Yep, connected to Mongo. Now, if I do a PS, we have 7777, which is exposed externally. And of course, that if you're doing this in your EC2 instance, be careful with, even though you're exposing here on the host, and in theory it's open, if the security group of the instance does not allow traffic to these ports, it still won't work. So you need to first expose the port with Docker and also open the security group that is assigned to your EC2 instance. Great. Coming back to the application, so let me reload this. I have my network monitoring tool open because I'm going to need it. If I log in, boom, I can see all the tasks. And if I go back to the task, what's the flag? So the flag is going to be, so one of the last API calls made is /tasks. And I need to analyze that API call and grab the number of bytes of the payload that contains all the tasks. Okay, what does that mean? So the last one, you see the file, which is like kind of the endpoint, is tasks. If I click on it, there's going to be a bunch of information here. And what we're looking for is the length of the content that is coming back from the backend, which is the 754 bytes. And you can also see here the size. I think if you're using Chrome, you're going to see a number like this, but it's going to be different. But that's basically the size of the headers, right? Which is different than the size of the content that is coming back. So if I click on response, you've got a JSON object, and that's what we're looking for. That's the size of the JSON object. So 754. Okay, so flag, oops, CTF, oops. 754. And there it is, last task, task number 10. Should we go to the last question? See who the winner will be?
Let's do it. Next question. So while we're waiting, I'll say that I just a few minutes ago, I closed the survey that we had open. I had shared the link for everybody to answer. So I drawed the name and we'll be announcing the winner after the quiz. And because we'll have two winners, one for the quiz and one for the survey.
Awesome. And I guess just to clarify, if someone doesn't understand the syntax, so when you have a backend underscore IP and then $sign and a command within parentheses, it's just basically executing that command, bringing back the result and using it in the command.
Another 5. Okay, let's do it. Last question. Find our winner. Did anything change?
And
there's some movement, but Magno's still on top. Awesome. Well done, I think. Next question. It's the end of the quiz. So what does it tell us?
Third place, Akshay. Second, Victor. First one, Magno. Awesome.
Well done, guys. Well done. Okay, so let me remove my screen. That's pretty cool. Did you have anything to share on your screen again?
No, that's pretty much it.
You're good. You're good.
Good.
Well, as for the stats that I shared in the beginning, I forgot to mention how long it took. So we only had 2 teams that ended up finishing the challenges during the CTF. The first 2 team. The first team emergency meeting finished in 2 hours and 13 minutes, and the second team finished about 20 minutes later at 2 hours and 35 minutes. And I'm pretty sure that Gambiara finished just seconds after the CTF finished, because I remember one of the players saying, "It did take the last flag," but it was like at the last few seconds. So that's pretty impressive.
It seems that they obtained the flag and then we closed it. So they didn't submit it. Yeah.
Not quite, but they still got 3rd place. So that was it for the data. As for the winners, well, we know that Magno, I know how to reach you. I'll send you your prize. Oh, we didn't say what it was. It's a 6 months subscription to Pentester Lab for the winner of the quiz. So congratulations. Hopefully you'll enjoy that. As for the survey, here's our survey winner. It's IC He was yes, I remember that username from Sunday. So thank you for participating, for giving us your answers in the survey. That's really, really useful, because we have plans for more, at least one more, and we're taking all this feedback because we learned a lot. I think it went pretty well. We're pretty happy with how it went. I think you are too. In general, I feel like everyone I was pretty satisfied. Not everyone, but a large majority. So we'll take whatever comment we had to make sure that we integrate it to the next event for sure.
Exactly. And I just want to, thank everyone for participating of the event, for participating also of the quizzes here in the live stream, all your feedback as well, right? That you send via the survey. It's very helpful for us to keep improving this event. And, like I said, I think I mentioned on Twitter, just rest assured that we're going to keep doing this, because we know that, people like this format. So we're going to be bringing more CTFs for everyone.
That's awesome. What I'll say for DevSlop, we have another show coming up on Sunday. I'll show that on the screen. We have Holly Grace Williams coming in and talking about automating application security testing is hard. It seems to be a very popular subject. You guys have been signing up like crazy on our meetup page, so for sure we'll be seeing you on Sunday about that. So yes, follow us on Twitter, on LinkedIn, on our YouTube channel, subscribe and follow us because we have plenty of content to share with you multiple times every month. And I'll add, do you want to talk about your project, Renan? Because you do this more than this. You've been helping us out a lot with the CTF, and we're super grateful to collaborate with you, because I think it's a great match between our communities to do this. But you do things on your own. You do other events, and you also create more content. So tell us, I think it's worth to take some time to tell us about that.
Of course, yeah. So what I did for the CTF, so since I'm not from the security side of things, I didn't really do a CTFs before, right? So that was new to me. Nancy introduced me to CTFs, and so the content that I create is basically for an event which I call the Dojo. I've been talking about here in this channel, quite a bit, and it's an event which is exactly like the CTF. So it's purely hands-on. And there's going to be either one or more topics. So just to give you an idea, this year we did a lot of things on AWS, like with code pipeline and some open source tools, networking as well on AWS with Transit Gateway, Nomad, which is a product from HashiCorp. So every 2 to 3 months or so, I run these events, which is not a competition like CTF. It's not like submitting flags, but it's basically just building solutions with others, networking with other people, and then after each one of these events, I either do a live stream on my Twitch channel about the solution for that event, for that challenge, or I record videos and post on my YouTube videos or YouTube channel so people can watch and on demand later. So if you're interested in participating, not only from the CTFs but also of the dojos, feel free to reach out to me either LinkedIn or Twitter, and I can show you the meetup group that we have for those events.
You do have a meetup group, so it's how do you find it? It's a Dojo with Renan or
No, it's a different one. I could grab the link. And,
I'll put that in the description.
Yeah, we'll put it in the description later.
That's awesome. So thank you so much. Funny thing about the CTF, I remember explaining we do CTF and security. And I remember the first flag, it was just a word. I'm like, no, we need to be cooler than that. We need a flag format and like curly brackets. So it was fun collaborating to do that. So yes, thank you everyone. That's all we have for today. That was a long 2 hours, but you stuck around. But the recording stays on the YouTube channel. You have the GitHub, the environment. How much time do they have in the AWS environment, Renan?
Yeah, so I'll live for an hour more for those who are still doing, and then later after that, if you don't have access to your AWS environment and you want to learn how to do in your own AWS account, feel free to reach out to me on Discord or LinkedIn. I can show you how you can set it up.
Okay, so thank you everyone, and have a great rest of your day. Take care.
Take care.
Bye.
Bye.